Today I'm going to be setting up a file server on a Raspberry Pi. I'm going to make it accessible outside of my home network using an overlay network VPN. Plus I'm going to set up a reverse proxy that will allow me to access these services with SSL encryption and any other services that I set up in my home lab. Yeah, if you're interested in seeing how I do this, strap in, because this is going to be a long one. So today's video was inspired by a couple of viewer comments. I had one person mention that they were interested in setting up a file server on a Raspberry Pi 5. They said they were going to use a 5, but in this video I'm going to be using just the Pi 4, the 4 gigabyte model. I've also had a couple comments asking me how to set up DNS on Cloudflare. So I'm going to cover both of those things today, but really this video is 3 separate topics. It's going to be setting up a file server on a Raspberry Pi. It's going to be setting up an overlay network VPN. I'll be using ZeroTier on this one because it's what I'm familiar with. And setting up DNS and reverse proxy so that you can access your home services from anywhere. So I'm going to start with the file server, and one thing to consider if you're going to be setting up a file server on Raspberry Pi is how you're going to configure your storage. In this particular video, I'm just going to be using a USB connected external hard drive with its own power supply. But something like this is a great option. The Argon Eon case by Argon 40 here, it'll allow you to install 4 separate hard drives. 2 3.5 inch and 2 2.5 inch in a nice compact and I think elegant looking enclosure. The only thing that kind of is limiting, it's through a USB connection, which you can kind of see here on the picture. So it's not going to be the fastest storage, but it will give you a clean NAS setup. If you're using a Raspberry Pi 5, I would highly recommend this case, also by Argon 40. It's got an NVMe storage slot in the bottom, and it'll actually allow you to use PCIe speeds on the storage. So it's pretty quick. And the only reason I'm recommending this one is it's what I use personally, and I've really enjoyed their product. Yeah, I may have just pointed out 2 Argon cases, but I am not affiliated with them at all. So the first step in setting up our file server is to image a base Debian install on a micro SD card. And I'm going to use the Raspberry Pi Imager here because it's a very excellent program that Raspberry Pi has produced. You can go to raspberrypi.com/software to download this, and you can see here they've got links for whatever operating system you're using. So if you got Windows, you can click here, Mac, click there, or Ubuntu, you can click here. I'm using Pop! OS, and it's actually available in the Pop! Shop, so I have already installed it that way. So I'm going to switch over to the Raspberry Pi Imager, and I'll show you the install there. So this Raspberry Pi Imager is really simple to use. First thing you want to do is choose your device. If you have a Raspberry Pi 5, then you would select that here under Choose OS. For what I'm doing, this is a headless install, so I would go with Raspberry Pi OS Other and choose the light version of it. Since I'm using a Raspberry Pi 4, I'm going to switch to that, and I'm going to choose the exact same operating system under Other, Light, and then choose your storage. I've got a 128 gig micro SD card that I've got in a memory card slot reader. So I'm going to select that. I'll click Next. And on here, it asks you if you want to apply customization settings. And since this is headless, I definitely do. You want to set a host name. I'm going to call this NAS. But since I've already got a NAS on my network, I'm just going to put an arbitrary letter beside it. I'm going to set the username and password. I don't have to configure Wi-Fi on here because this is going to be connected via an Ethernet, but I do want to set the locale settings. And then under services, I want to enable SSH, and since I have a public SSH key, I'm going to copy and paste that. And I'll check the other options. I don't think there's anything else. Nope. So I will save that. And I will say yes, apply the OS customization settings. And this last little pop-up is warning you that everything on that SD card is going to be erased. So in my case, I know there's nothing important on there. I'm going to say yes. And since I'm running this on Linux, I'm going to get an authentication pop-up. So I have to enter in my password to authorize the writing on this SD card. So this is going to take a couple minutes, so I'm just going to fast forward through it. So the image has been successfully written to the micro SD card and it's ready to go. So I'm going to pull it out of my laptop, I'm going to pop it into the Raspberry Pi 4, I'll boot it up and we'll carry on from there. So my Raspberry Pi is booted up, and it took a few minutes because when you're booting up your Raspberry Pi for the first time, it has to resize the file system. So after this point, it shouldn't take as long to boot up. But now I'm ready to install Open Media Vault, which is what I'm going to use for the file server software. So I'm going to switch back over to my browser, and I'm going to go to this Open Media Vault install script page. I found this right off of the Open Media Vault forums, and I'm going to scroll down, and there are 3 different ways to install it on here. These 2 are effectively the same, just one grabs the install script with wget and the other one with curl. And the third one here will not touch your networking setup that you've already got on your Raspberry Pi. This is the one I'm going to use because for some reason, whenever I use this script, it messes up with my DHCP reservations, and I've already got it set to the IP address that I want it to be on. So I'm just going to copy this. I'm going to switch over to my terminal, and I'm going to paste that command in here. And this is going to take a while, so I'm going to fast forward through all of this. Alright, so the install script is run. It took about 18 minutes, and Open Media Vault should now be installed on my Raspberry Pi. So I'm going to switch over to my browser. I'll open a new window and I'll navigate to that IP address. And it looks like it installed successfully. So I'm going to log in. Open. The default password is Open Media Vault. I'm going to type it correctly this time. And there's a couple things I want to do in here right off the bat. One is to change the password for the admin. Oh, for crying out loud, I'll type that correctly this time. And I also want to change the password for my user. I need to do this so that I can access my network shares. No, I don't need to add the SSH public key. So we'll save. And I want to apply these configurations. So now that I've got those out of the way, I also want to update the system. And now that this NAS is up to date, I'm ready to turn it into a file server by adding storage. So I'm going to look at my disks, and I should have a 4 terabyte external drive on here. I'm going to wipe this so that I can use it. I have nothing on there, so I'm sure of that. We're just gonna go quick. I gotta put a file system on it. So in this, I'm gonna create and mount a file system. I'm gonna put ext4, and I'll select that disk I just wiped. Once again, this is gonna take a while. So I'll fast forward it so you don't have to sit through all of it. And 11 minutes later, that file system is ready to go. So I'm going to go back to File Systems. We'll mount an existing file system, select that drive, and hit Save. And then Apply. Now I need to make a shared folder. I'll just call this one the same as my device, select a file system, and save. And apply. And now to make this accessible, I need to start up the SMB service. I'll go to Settings, I'll enable it, I'll save that, and apply. And then I have to set up my share. I'll select that NAS-T, and I think that's all I need. I will save and then apply. Okay, so now my file server should be set up the way I want. In order to test it out, I'm just going to switch over to my file browser. So to test this out, I'm going to switch to other locations. I'm going to enter in a server address, smb.// and you can see here this is the second time I've tried this. But this time I'm going to use the IP address. Oh, no, 192.168.240.99, and we're going to call this one NAS-T. And we'll connect as a registered user. I'll enter in my password, and we'll connect. All right, I'm going to create a new folder just to test out the write permission. I'm just going to call this one temp. And you can see we can write on this share. So my file server is now set up. Now to make my file server accessible outside of my home, I'm going to use an overlay network VPN. It's done by ZeroTier. I've used this before. It works really well. It's not perfect, but for most scenarios, it's fine. It primarily uses what's called UDP hole punching. So if you're interested in it, check that out. It's quite interesting how it works, but I'm not going to get into that today. I will show you how to set it up. So if you come to ZeroTier.com, you just click sign up, you create an account, and then you log in, and that's what I'm going to do right now. So I'll be right back. All right, now that I'm logged in, this is what you're going to see. You can create separate networks for different services that you're going to use. It is free to use up to, I think, 22 devices. I'll double check that and I'll put it in the video if I'm wrong. But in order to start using this, you need to click Create a Network. So in order to use this network, I'm going to need ZeroTier installed on my Raspberry Pi. And to do that, I'm going to right click on download and open it in a different link or in a different tab. And I'm going to scroll down to where it says install using Linux. So I'm just going to copy this one-line command here. I'm going to switch over to my terminal. And I'm just going to paste that right here. Alright, now that ZeroTier is installed, I can use it to connect to the ZeroTier service. So I'm going to switch back to my browser. And I'm going to go back to my user interface. And I'm going to click on this network. I'm just going to copy this network ID. And I'm going to use the CLI tool on my NAS to join to this network. So I'll switch back to the terminal. And I'm going to use the command sudo ZeroTier CLI join, and I'm just going to paste in that network ID. And it says join OK. So I'm going to switch back to my browser, and I'm just going to refresh this page. And you can see here there's a new device, but it's not authorized to access anything on this network yet. That's what's kind of nice about ZeroTier, is you have to authorize every device that connects. So I'm going to authorize it. And now we've joined that network. I'm going to refresh this again. And you can see it's assigned an IP address to that NAS. Now I can do the same thing with my laptop, so I'm going to go ahead and do that, and I will be right back. Okay, now that I've joined with my laptop, I'll refresh the page again, and you can see there it is. I'm going to select that and authorize it to join this network. And I'll refresh this again, and you can see my laptop has also been assigned an IP address. Now, if I am outside of my home network, I can access this IP address to get to my NAS device. And that's basically all there is to it. There's no need to implement any rules in your network firewall. It will just reach out to a third-party server with ZeroTier, and ZeroTier will connect the two devices directly using this UDP hole punching. So that's basically it for setting up the overlay network VPN. So now that I've got my file server set up, I've got my overlay network set up, the last thing I want to do is set up some DNS records so that I don't have to remember all these IP addresses. It also has the added benefit of me having two separate DNS records, one for while I'm in my home and a second one for when I'm out and about, so that when I'm within my home network, I can access my file server directly, and if I'm out and about, it will automatically try to reach the file server through the VPN. So to create a local DNS record, I'm going to sign into my Pi-hole with the right password. And I'm going to go to local DNS records, and I'm going to create a DNS record that points to nst.hardwoodhomelabdemo.xyz, and that IP address was 192.168.240.99, and I'm going to add this record. Now this will be great for when I'm accessing the file share internally. So I'm going to switch to my file browser to demonstrate this. Now here on my file browser, if I go to other locations and I enter smb://nast.hardwoodhomelabdemo.xyz, I'll have to sign in again. But you can see I've got access to my file share It's the exact same one that I did through the IP, but it shows it as two separate shares. So I'm going to unmount this one, and I'm going to bookmark this. So now if I'm out and about, if I click on this bookmark, it's going to resolve via the domain name instead of the IP address. So this one bookmark will allow me to access my file server from inside my network and outside. But in order to resolve this outside of my network, I need to create a DNS entry. So I'm going to switch back to my browser, and I'm going to switch over to Cloudflare. So in here, we're going to have to create a DNS record for my NAS device. So you're going to have to sign up for a Cloudflare account, and for whatever registrar you purchased your domain from, you're going to have to set up with them that your DNS is through Cloudflare. Now, once you've logged into your new Cloudflare account, they've got very clear instructions on there on how to do that. I'm going to sign into my Cloudflare account, and once I'm done with that, I'll show you the next steps. Okay, so once you've signed into Cloudflare and you've linked your domain to it, this is going to be your home page. So in order to set up a DNS record, I'm going to click on my domain, and on the left side here, there is DNS. So in here, I want to add a new record. I'm going to use an A-type record, and this one is just going to point to NAST, and as you can see, this will be the full domain. I don't want to proxy this because it's not using a public IP address anyway, and what I want to use is the IP address that was given to my NAS from ZeroTier. So I'm going to select this IP address, I'm going to copy it, I'm going to move back over to Cloudflare and paste that in here. You'll note that this is not a public IP address. If you're familiar with the IP spaces, this one is private, probably very similar to the IP address that your router is using. So that's where I want this domain to point to. So I'm going to save this. And now, anytime I'm outside of my home network, this domain is going to resolve to this IP. And inside my home address, it's going to resolve to this IP. So that's basically all there is to setting up DNS records on Cloudflare. But the last thing I want to set up is reverse proxy. By having reverse proxy, I'll be able to access any services that I've got set up, even if it's not on my file server. But the first thing I'm going to set up is a new service on my file server. And in order to do that, I want to set up a plugin. It's Open Media Vault Compose. I'm going to install this plugin, which is going to allow me to use Docker Compose files to run up Docker containers on this Raspberry Pi. So I'm going to install that. I'll confirm it and say yes. Now, with that plugin installed, I also want to go to System, OMV Extras, and I want to click on the Docker repo. So this will enable Docker support on this Raspberry Pi. So now that Docker support has been enabled, if I look under services, I can see Compose is here, and I can add Docker containers. But in order for me to add those Docker containers, I need to have a space for storage. And to do that, I'm going to create a new shared folder. I'm going to create this. I'll just call it Docker. I'll select my external hard drive for storage, and then I'm going to save that. And then, of course, apply changes. So now that I have a location for Docker to store its data, I'm going to go back over to Services, Compose, go to Settings, and then choose that shared folder that I just created for Docker. I got to save that, and then of course with Open Media Vault, I'm going to have to apply the changes. So since I'm going to be setting up a reverse proxy on this NAS, it's going to want to use port 80 and 443, which are the standard web ports. And that's what Open Media Vault is now using. So if I look at the workbench, you can see on here that we're using port 80. Now if I try and spin up an Nginx proxy manager, which is what I'm going to use for reverse proxy, it's going to conflict with this port. So I'm going to have to change this. I'm going to switch it to port 82, and that will alleviate any conflict. The problem with that, until I've got my reverse proxy set up, is that I have to remember port 82 in order to access any of the Open Media Vault settings. This will only be the case for a few minutes, so I'm going to save this. It's going to ask you to apply. And I'll say yes. And that's going to reboot the Open Media Vault web interface, but it's going to reboot it onto port 82. So I'm going to have to get rid of all of this and tell it to look on port 82. Now that we're running on the different port, I can sign in and I can create my Nginx Proxy Manager reverse proxy. To do that, I'm going to go to Services, Compose, I'll go to Files, and then I have to create a new file. So I'm going to add a new file. I'm going to call this npm for Nginx Proxy Manager, and I'll even put that in the description. And then I want to go to the Nginx Proxy Manager site. So from nginxproxymanager.com, I want to go to Get Started, Quick Setup. I'm going to highlight all of this. I'm going to copy it, and then I'm going to paste it in here. So I'll save this file. And now we're ready to start up this container. So I'm going to select it and tell it to bring it up. As you can see here, it's downloading the image, and once it's done, it'll start it up. Alright, now that we've got the Nginx Proxy Manager running on here, I want to log into it, and I know that it runs on port 81. So I'm going to go to port 81. I have to do the setup, so it uses admin@example.com with the password of change me. So we'll sign in. I'm going to change this to the same thing as before, if you watched my other video. And I'm going to call this Hardwood Home Lab at home.local. Local. Now I got to change that password from change me to a super secure password. And on here, I'm just going to use a wildcard certificate as well as I did on the last one. So I'm going to add an SSL certificate. I'm going to give that one an asterisk for a wildcard, and it'll be Hardwood Home Lab demo.xyz. And because this is behind my home firewall, I have to use a DNS challenge. I'm going to choose my provider, which is Cloudflare. And in order to get this API token, I have to switch back over to the Cloudflare. I'm going to go to Overview, and I'll scroll down here and get your API token on the right. I'm going to create a new API token with edit zone DNS. So I'm going to use that template. I'm going to change this for, I'm going to call this NAS T underscore demo. And you want it to have zone edit permissions. So I will continue to summary. Oh, I have to select a zone. I'll continue to summary and then create token. Now it's only going to show you this token once. So once you've left the screen, you can't access this ever again. So I'm going to copy that. I'm going to switch over to my Nginx Proxy Manager and I'm going to paste that token in here. I'm going to agree to the Let's Encrypt terms of service. I'm going to change my email address to a legitimate one, and I'm going to click Save. And when I do that, it's going to reach out to Let's Encrypt and create a wildcard certificate for this domain. Okay, now that I've got my wildcard certificate, I'm ready to add some hosts onto this reverse proxy. So I'm going to go to the dashboard, select proxy hosts, and I'm going to add a proxy host. The first thing I want to add on here is the file server software so that I don't have to remember that IP anymore. So I'm going to call this, what was it? nast.hardwoodhomelabdemo.xyz. That was the IP address of this particular machine, which is 192.168.240.99, and I put that service on port 82. So I'm going to go to SSL, grab my wildcard certificate here, and force SSL, and I'll click Save. And in a new tab, I'm going to try that out. So that was nast.hardwoodhomelab.demo.xyz. And as you can see, I no longer have to remember that IP address. This will also work when I'm outside of the home. So if I'm on, say, or at a coffee shop, I can access this domain and be able to reach my Open Media Vault instance. So with this example, you can see that the reverse proxy can point to services that are running on Open Media Vault. But I can also point it to services that are within my home lab. So I'm going to go to my Proxmox instance. And I'll show you that I set up a demo web server on here. Called it temp web server because I'm going to remove this once I'm done with this video, but you can see it's running on 192.168.240.105. So I'm going to create a new host on here. I'm going to call this WebT at hardwoodhomelabdemo.xyz. And it's important to hit enter after you've typed in your domain, otherwise it doesn't recognize it. So don't forget that. That's something I've been guilty of. And I said that was at 192.168.240.105. And that was on port 80. Make sure you enter that in there, even though it does show 80 on there. I'm going to use my wildcard certificate again and force SSL, and I will save that. And now, if I go to webT.hardwoodhomelabdemo, nothing happened because I didn't set up the DNS record for it yet. I have to go to Pi-hole, DNS records, and I can add the domain and point it to the IP address of nast. But what I'm going to do is create a CNAME record. So with this CNAME record, I'm going to point, that was webT.hardwoodhomelabdemo.xyz, and I'm going to point that to nast.hardwoodhomelabdemo.xyz and add that. Now, for if any reason I changed my reverse proxy IP address now all I have to do is change it under DNS records once instead of for every domain that's pointed at that reverse proxy. So I'm going to retry loading this again, and you can see it worked. So I can access this web server through my reverse proxy. I can access Open Media Vault, and I should be able to access those two things from outside my home network using that VPN. And that's kind of how I wanted to set this up. To demonstrate how well this works, I went out to a local coffee shop. Here you can see me connecting to their Wi-Fi. Now that I'm connected, I switched to another workspace and opened a terminal to run the dig command on my domain. You can see right here that the IP address that was resolved is the one assigned by the ZeroTier network. I pinged the domain to show my connection to my Raspberry Pi at home. Then I accessed Open Media Vault in the browser and my temp web server. Remember, that web server is not running on the Raspberry Pi, so that Pi is acting as a proxy into my home lab. Now that I've shown I can access the web services, I switched to my file browser to show how seamlessly I can connect to the SMB share that I set up earlier. And it would have been a lot easier if I saved the credentials. I downloaded an image just for something to drop into my NAS at home. It was simple to place that file in my remote storage. And then I ran home to show that it was accessible on my home network. The dig command here was just to show that the domain was now resolved to my home IP. And I can still access that duck image. With that, my Raspberry Pi file server is done and working how I intended. I hope you found this interesting, and thanks for watching.